Hi, now we are going to see queues. What is queues in general, right? When you stand in a queue to get a ticket in a ticket counter, right? The person who stand in the line first will come out first, right? The same way, the people moving on the escalator, the people who got on the escalator first will be the first one to step out. Okay, the people waiting for the bus, the first person standing in the line will be the first one to get into the bus. Okay, the luggage kept on the conveyor belt, the bag which was placed first will be the first to come out, right? So, in all these example, we see that the element at the first position is served first, which means the queue works in the fashion of the queue works in the fashion of first in, first out. Okay, right? The element at the first position will be served first. Okay, right. So the element in the queue are added at one end. Okay, the element in the stack, right? We add and delete the element only in the top, right? But here in the queue, the element will be inserted in one end and deleted in other end. Okay, inserted one end and deleted in other end. Okay, so the elements in a queue are added at one end are called rear end, and removed from the other end called the front end. Okay, the queue can be implemented by using either arrays or linked lists, same way like a stack. Okay, now we'll see array implementation of stack. Array implementation of stack. So in this place, right, the queue can be represented like this. Sorry, it's a representation of implementation of queue. Okay, so let me just add right? So let me just take this as an initial. Okay, right. So in the beginning, so what is the what is the representation says, right? So the queue has two end, right? So one is the front end, other one is rear end. So the elements will be added at the rear end, and the deletion will be added in the deletion will be done in the front end. Okay, right? So according to this diagram, the front is equal to 0. So this is what the index number we do, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Right now the front equal to 0 and rear is 5, and the rear equal to 5. Okay, suppose we want to add an element. Okay, add element 89. Okay, so what we have to do, let me just copy this entire thing. If I add 89, right, now the front equal to 0 and the rear is 6, right? So first what we did, we just incremented the rear by 1 and then add the element. This is the logic. Okay, whenever we insert, so increment the rear by 1 and add the element at the position. Okay, add the element at the position pointed by the rear. Right. So the queue after addition is shown in the above figure. Right. Now next we are going to see, every time whenever we next we are going to see how to um, what are the checks that we have to do before insertion, right? So we have to check the overflow condition. What is the overflow condition? So here the maximum size is 9. Whenever the rear value is equal to max minus 1, so, or suppose the max value is 10, that max means the size of the array. Okay, whenever the size of the array is 10, it will be good to know, right? Okay, it will be good to know that whether the sizes, I mean the space is available or not. Okay, so every time the new element has to be added, okay, we repeat the same procedure. Suppose if we want to delete an element from the queue, okay, what we have to do, we have to increment the front. Very simple. To delete an element, okay, increment the front. Okay, right? So how do we do it? Let me just copy this. Okay, so increment of friend means what? The friend is to be treated 3. Okay, so here friend equal to 1 and rear equal to 80, rear equal to 6, which means so one element is deleted. Okay, deletion are done only at this end of the queue. Okay, deletion done only this end of the queue. Okay, the queue after deletion will be like the diagram shown above. Okay, now we'll see the algorithm. Okay, algorithm for insertion. First, algorithm for insertion of an element in the queue. First step, what's the first step? Check, right? So if real equal to max minus 1, what is max? Max is the size of the array. So as I told you, the size of the array is fixed, right? Okay, so if it is so, just print overflow. Okay, so if front equal to -1 and rear is equal to -1, set front. Okay, whenever the front front is -1, rear is -1 means there is no element, so we have to increment it, right? Okay, so increment both front, set front and rear equal to 0. Okay, otherwise okay, it is else part. Else increment the rear is equal to rear plus 1. After incrementing rear only, we have to go to the next step, which is set the queue of rear equal to the value. Okay, next is end. That's all. Algorithm is very simple, right? Okay, now how to delete the element? Okay, so before deleting element in an array, we need to check whether the array is empty or not. Okay, if front equal to -1 or front is greater than rear, this we have to check. Okay, so what is this first check? We are checking whether it is underflow or not, right? Okay, and the underflow occurs when the front is -1. So front is -1 means what? There is no element in the front, which means queue is empty. Okay, and also sometimes the front may be greater than rear. Okay, so however we need to, however if the queue has some values, the front is incremented. Okay, so that it now points to the next value in the queue, right? That's why we have to put first check print underflow. Next, the second point, it's not the second point, the first one itself, else set value is equal to, just taking the before incrementing it, first I'm taking the value of the current position. Okay, current position of the front. Next is what? Set front is equal to front plus 1. Okay, which means just increment. That's all it in. Only this step, only 2 steps. Simple, right? Okay, so this is how we can perform an insertion and deletion. Now let's see how to implement this in C program. Okay, that's what our intention is, right? Okay, fine. So first hash include slave.h hash include conny.h. It is not required. Let's define max of 10. Okay, next is what? Next I have to define what's the front at initial stage. Front -1 comma rear also equal to -1, right? And then you have to start with main into main. Okay, so first how do I insert it? First I have to give one value int number printf, enter the element to insert in the queue. Okay, and then scanf %d comma ampersand number. So I got the number to insert. Okay, next I have to check what if before insertion I have to check whether it is equal to max -1 or not. Okay, if it is so, what I have to print? I have to print it's a overflow. Okay, else if front equal to -1 and rear equal to -1, then front is equal to rear equal to 0, else rear plus plus. Okay, this is what rear is equal to rear plus 1, right? Okay, and then after incrementing the rear, just to make the queue, right? We didn't create an array. We need to create an array called queue. Int queue of size 10. Okay, so queue of rear equal to num. So this will insert the in the queue. So after insertion, we need to display, right? Okay, so how do I display it? I have to use obviously the queue, right? So use a for loop. So for int I equal to 0, I less than rear I plus plus. Okay, then printf %d. Okay, comma q of I. So if we give a /d, it gives you a tab. Okay, let's save this as qi. So I do enter the element which I want to insert. Okay, let me give 10. So I just given 10. So we have to put less than or equal to 0 here. So let me check now. 88, 99. Yeah, it is printing 99. Okay, so if you want to keep calling the insertion, right, so we need to write it in the function. Okay, so we need to write it in the function. Let me just hard code it. Okay, so I'm gonna write okay, so this is what the for insertion. This is for insertion. So let me make it as Control X and void insert. Paste it. Okay, let me just give a gap, and then this is for deletion. Display. Void display. Control V. So and that's why I made a rear value as a global. Okay, whenever I increment it here, it will be assigned to the display. Okay, suppose if I want to insert, right, insert, I have to pass some value, so let me make it as a int null. Or I can, what do you want? Whenever I insert, let me take this only. Okay, this is for insertion, and after insertion I'm going to display. Suppose if I'm going to add a two element insert, I'm going to call insert. Again I'm going to call insert. Okay, again I'm going to call insert. Then I'm going to call display only one time. So let me call my scene. So first call I inserted. Okay, let me insert 12. Next let me insert 13, let me insert 14, 12, 13, 14. This is my queue. Okay, what is the next one? The next one is we have to delete the element. So how do you delete? So in insertion we increment at the rear and place a value. In deletion we have to decrement the rear. So what is the condition before deleting the queue? Void delete. So I need to check if, so what we have given here, so we need to check the rear, the front, and front is greater than rear, rear or not. Okay, so I'm just copying that and pasting it. The front is equal to -1, or means here it's a pipe symbol. Okay, or greater than rear. Okay, so this is the condition for printing underflow. Print underflow, the stack is empty. Okay, then what's the next condition? Else I need to have one variable called int value. Then value, this is for storing the current element of the front, queue of front. Queue of front. So we want to take the first, and then what we have to increment the front. So front plus plus, right? So after incrementing the front value, we need to say which value we have deleted. Okay, suppose in that case, if my front value is greater than rear, okay, if my front value is greater than rear, what we have to do? We have to make the front and rear as 1. Okay, so if the condition, if this condition is not met here, it will give you what? Underflow. Only this condition met means it gives you underflow. And suppose if after deleting it, okay, suppose in that case if the rear and the front is same, okay, which means only one element is there. Okay, so if you delete it means what? I have to make it as what? Say for example, in this place only 89 is there. Assume only 89 is there. Now what is the front and rear? Both are 6. When I want to delete 89, what I have to do? I have to move the front to 7. Am I right? Okay, so when there is 89, both are in the 6. When I delete it, what I supposed to do? But increment the front. So front will become what? Front will become 7 and rear will become 6. Am I right? Okay, so if front is greater than 6 means I have to make the front and rear as -1 because I have to move that to the first. Okay, so that's why we have to make front and rear as -1 in our code. So if after deleting, if front is greater than rear, after incrementing front is greater than rear, okay, what we have to make? We have to make the front and rear equal to -1. Front equal to rear equal to -1. Both will be -1. Okay, then just print the value which one we have deleted. The deleted value is personality, comma value. Okay, so this is what we have deleted. So we have to give delete and then again display. So it's asking me 12, 13, 12, 12, I given 12, 4. Okay, my data value is 12. Let me give a new one that is incremented the front or not. Okay, so give a new line here slash in. Okay, and add I think to be 10. So it printed the content. I given slash in, so it gives a dated value. Again I given display. Okay, so display means here also I have to give slash in. Okay, right, let's check. 12, 13, 14. So 12, 13, 14 is the content. I did it 12, but it is displaying 12. Why? Because we have not done we initialize a value from the 0. We have to initialize a value from the front. Here the display, it should be what? It should be front. Okay, now if you run 11, 12, 13. Okay, see the 12, 13 is the content. Updated value is 11 and the 12, 13 is the content. So this is how I can implement the queue using array.